This is part 2 of our lesson 5.4. We're going to look at altitudes of a triangle. An altitude is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So here's a good example of an altitude. If you've ever heard the word altitude before, it generally refers to the height of something. So if you were going to measure the height of this triangle, what you would do is you would measure it at its tippy top point all the way down to the other side and make sure you measure it on a right angle. So you're measuring straight up and down, not on some goofy angle. So this is an acute triangle right here. This altitude touches that vertex Q and is perpendicular to segment PR. Now, you could find an altitude from every single vertex if you wanted to, but every time you have an acute triangle, the altitudes are going to be inside the triangle. When you have a right triangle, there's an altitude that lives on the triangle. Notice how it goes from the vertex and it is perpendicular to one of the sides. If you have an obtuse triangle, the altitude is actually going to live outside the triangle for one of the vertices. So this vertex Q, perpendicular down to this segment, PR, that's your altitude. Each triangle has 3 altitudes, and they're concurrent. The point at which the lines containing the 3 altitudes of a triangle intersect, that's called the orthocenter of the triangle. So if I would draw 3 altitudes on my triangle, now you have to imagine that this comes through here and connects this vertex. Same thing with this guy. They're going to connect at that point P. That's the orthocenter. When you have an acute triangle, point P is going to be inside the triangle. When you have a right triangle, here's your altitude. Here's another altitude. Here's an altitude from this side. Point P would be your orthocenter. Notice how it's on the triangle. And when you have an obtuse triangle, like we had on that last slide, that point P is outside the triangle. Let's take a step back and look at isosceles triangles again. In an isosceles triangle, the perpendicular bisector, that would be this guy because it touches this midpoint at a right angle. The angle bisector, that's this guy because it splits this angle. The median touches the vertex and this midpoint. And the altitude touches the vertex at a right angle. They're all the same segment. So this segment is everything that we've talked about so far in this chapter. This segment right here is a perpendicular bisector. It's an angle bisector. It's a median, and it's an altitude. That's when you have an isosceles triangle. In an equilateral triangle, this is true for the segment from any vertex. So this isosceles triangle, this segment is all of those things from this vertex. Now, if this was equilateral, then it would work from every single vertex.